Today we're continuing on talking about limits. Remember example 3 from yesterday, the Heaviside function? We were looking at the limit as x approaches 0. And notice that there was a huge jump. Either the electrical current was off or it was on. So looking at it from both sides did not give us a limit. But what if we only looked at it from one side? So coming in on the left side, okay, approaching 0 from the left, what is f of x approaching? Well, it's approaching 0. But as we approach 0 from the right side, f of x is approaching 1. So if we take the limit, we don't get anything. But if we take a limit, such as the left-handed limit or the right-hand limit, then we do get something. And that's what we're going to talk about today. Definition of a one-sided limit. Here we have the left-hand limit of f of x as x approaches a, or you can say the limit of f of x as x approaches a from the left. Okay, so to find a left-hand limit, you take values approaching a from the left side, values that are less than a, and then to find a right-hand limit, you take values that are slightly larger than a, approaching a from the right side, okay? The limit of f of x is, as x approaches a, is L, if and only if the left-hand limit is L and the right-hand limit is L. You only get a function where the limit does exist if the left-hand limit and the right-hand limit are the same. Find the following based on the graph at right. So this is asking us the limit of g of x as x approaches 2 from the left. Okay, here we have g of x as x approaches 2 from the left. What is happening to f of x? What's happening at 1? It's approximately 3. 1/2 is close to 3 as well. It appears to be approaching 3 from the left as x approaches 2 from the left. What about when x approaches 2 from the right? G of 3 is this. G of 2.5 is this. What f of x value am I approaching? I'm approaching 1. So the limit of g of x as x approaches 2, since the left-hand limit and the right-hand limit are not the same, then the limit does not exist. And we write D and E for does not exist. The limit of g of x as x approaches 5 from the left-hand side. As x gets closer to 5 from the left, we see values approaching this f of x, which is 2. Then from the right-hand side, we see values that are, again, approaching 2. The left-hand limit is 2, the right-hand limit is 2, therefore the limit does exist and it is also 2. So here we have a piecewise function with a parabola and a line. Let's go ahead and graph that. The first piece of our piecewise function is 2x squared, x is less than, if x is less than 1. Okay, so this parabola has a vertex at 0, 0, which is less than 1. When I go to the left, I'm going to rise 2 because of a vertical stretch of 2. So when I go to the left 2, I'm going to rise 8. Now, if I were to plug in 1, I would get 2. So the right-hand behavior of the parabola is following the left hand, of course, because it's symmetrical, but it's approaching 2, okay? But we are not including x equals 1 for the 2x squared, right? This does not include 1. So we have to graph a little hole at where that 1 would have gone. Okay, 4 minus x, this piece is a line. The y-intercept is 4. And it goes down 1 over 1. Obviously, the x has to be greater than or equal to 1, so the y-intercept is not valid as a part of our function, but I just graphed it to help me find where to start. Here's my line. All right. Is this a function? Yes, because here at 1 I have a hole, and here I have a solid. So the limit of f of x as x approaches 1 from the left-hand side. We're decreasing, 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 decreasing. You get to 0. You're increasing, increasing, back up. And as x is approaching 1 from the left side, you are approaching the f of x value 2. As x approaches 1 from the right side, we're increasing, 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 increasing. And what do we get? We approach 3. So this function has a limit. It has a left-hand limit, and it has a right-hand limit. But if these are not the same, the limit does not exist as x approaches 1.